dimensions of inflation have the property that once they start, they never completely stop. We call it eternal inflation. It's really future eternal inflation. It goes on forever, producing what we call pocket universes. And the difficulty with that is how to define probabilities, because everything that's allowed by the laws of physics will happen an infinite number of times in this multiverse. So it's very hard to know what you're talking about when you say that something is more common than something else. So people have been wrestling with that, and it's still pretty much an open problem. But we have a number of different proposals for how to extract finite numbers from the infinities. We don't even know what the right recipe is. But the recipes that give sensible answers seem to all have the property that they prefer small amounts of inflation rather than huge amounts of inflation. While in the old days, we used to think that huge amounts of inflation looked much more plausible.
So what's the implication of that?
One is that if you have a huge amount of inflation, it drives the universe completely to flatness, critical mass density. But if you have just minimal amount of inflation, then there's still a chance that we're not quite at the critical density and that we might measure a deviation from the critical density. So that now becomes a much more interesting thing to look for. The other important implication of minimal inflation is it means that our pocket universe is probably not as big as we once thought it was. In the, quote, old days, we used to think that our pocket universe was tens of orders of magnitude larger than what we currently observe.
You know, what happened before? How did inflation start?
Well, we still certainly don't know the answer to that question, and inflation, in fact, makes it a particularly difficult question to answer, because the gigantic expansion associated with inflation, really from an observational point of view, essentially completely erases any evidence of what came before. So thinking about what came before is pretty much entirely a theoretical issue.
What are some of the options? What are some of the differences that people are talking about?
One possibility that people have thought a lot about is the idea of a quantum origin of the universe, that's tunneling from something or not, some version of nothing, and there are different versions of nothing. But yeah, the idea is that somehow quantum physics can start with a state of nothingness and tunnel to a small universe which then undergoes inflation.
Allen's theory of cosmic inflation makes astonishing claims. Inflation transforms the smallest possible events, quantum fluctuations far smaller than an atom, into the largest existing structures, galaxies and clusters of galaxies. And once begun, cosmic inflation cannot end, so that an inconceivably large number of universes continue to be generated, perhaps an infinite number of universes. Among cosmologists, eternal cosmic inflation has become conventional wisdom. But even as observational evidence has been building support, not everyone is convinced, and I need to know why. I meet theoretical physicist Andreas Albrecht.
Andreas, most cosmologists believe that the theory of inflation is an accurate way to describe the beginning of the universe. And the general implications of that are two things. One is that our own universe is orders of magnitude, maybe exponentially bigger than what we currently see. And secondly, that the implications of math is that if inflation starts, it doesn't stop, so that there'll be maybe infinite numbers of other universes. So you agree with the inflation, but you question some of the conventional implications.
I do. If you believe in a little bit of inflation, it's very easy to conclude there must be a lot. But then it leads to some really weird stuff. I mean, inflation is advertised as a solution to tuning problems, where the universe itself looks delicately balanced at the beginning of the Big Bang. I think some people kid themselves. This eternal inflating picture is free of those problems, but I think it is. And that's forced me to consider something other than the simple extrapolation back that you might naively do with an inflation theory. And one of the things that's actually motivated that is the dark energy and the possibility that we're surrounded by a horizon not much bigger than what we see today that could really be the edge of the universe, not just the edge of what we see, but the edge.
I mean, that's really a minority position. Why are we able to see the edge of the universe? That seems unduly coincidental.
Well, there's a lot of talk about these coincidences. People wonder, why is the value of the cosmological constant, the dark energy, it is? Yeah. That's where that coincidence comes from. It's nothing other than that. It's not a new coincidence. But what I've done is take the quantum suppose the quantum theory of